Everybody ready on that side?
Yes.
You guys really ought to try our chocolates.
We don't have it.
That's nice.
Hang out, sorry.
Okay, so we are going to talk about the LCAPI. So first of all, just a little bit of history on this is that we had some folks from the SQL Server team at Microsoft who were creating this product feature called Stream Insight. And they wanted to make a streaming service for SQL Server that would allow you to stream data in and also stream data out in real time. So for instance, one of the models they did is they were taking all the shuttles that Microsoft runs, and we have the largest private bus fleet of any anywhere in the country that moves people around inside a campus as well as through their commutes. And so they're all GPS marked, and they're all tracked every 10 seconds. And they report in, and so they know exactly where the shuttle fleet is. And so they wanted to visualize that on a map in Worldwide Telescope and wanted an interface to be able to push data to us. And so we created, as we were trying to negotiate how they should call us and what technology we wanted and everything, one of the things we decided is that this new API that we're going to create to push data into Worldwide Telescope should be loosely coupled so that it can be called from any language, and that the language choice for this interface basically should be up to the consumer, and we shouldn't care what language they're using. And so since web services were gaining in popularity, we decided we would, even though this is a desktop application, we would make this interface look like a web service. Since Worldwide Telescope already had a web server built into it, we could leverage that web service as an endpoint to be able to send commands to Worldwide Telescope and get event notifications from Worldwide Telescope. And so thus the LCAPI was born. Later on, we decided the LCAPI would be a backronym for Layer Control API instead of Loosely Coupled API, because loosely coupled didn't seem to mean much as much to people, but it's still an important attribute about this. So what we're going to do here is we're actually going to load up the Worldwide Telescope and go ahead and load, because as we're doing examples of this, we're going to show how the API endpoints actually penetrate into Worldwide Telescope and how they work the way they do. And so we're going to be able to actually set breakpoints when we're calling the code from the outside. So today I'm going to show you some of the surface area of the API and some of the cool ways that the API can be used in terms of getting data in and pushing things in and some of its capabilities. But I'm going to be using some web browser examples as the way that I start exercising it, so that we can essentially kind of see, in a non-language specific way how it works. If you're going to work against the LCAPI, you have two choices. One of which is you can use it raw and build your own interface against it using HTTP gets and posts, or you can use a wrapper that already exists to be able to access it through an abstraction layer. One of those abstraction layers, which has also a lot of extra value added, is something called Narwhal. And Narwhal is a project also on GitHub that's one of the WWT projects that you can download that, and you can use that as a sample of as an API itself, or as a sample of how to access the LCAPIs, because it does a fairly reasonable job of it. We're also going to show you where LCAPI could be extended if you want to actually check code out and create extensions to LCAPI, because say you have a project that you can do 95% of everything you want to do with the LCAPI, but there's like one little piece missing. Well, the LCAPI can be extensible, so you can add additional elements to it. So I guess I realized I didn't share my screen, so you guys can't see what's on the screen here. So let's get back to sharing the screen here. And so here we are in the solar system mode. Since it's the layer control API, we're looking at the layer manager here, and you can see that we have our sort of core for where we care about this. The sun is sort of the root of this tree. And then we can go to like the Earth here, and we can see here's the International Space Station. Here's an ISS model here. Here's Mars, its moons, Jupiter and its moons. And you can add additional reference frames to it. So the LCAPI primarily will deal with getting the contents of the current layers that are existing, adding new reference frames, adding new layer groups, and adding new layers, and then updating parameters of those layers and updating data that is in those layers. So if anybody's used how many people have used the Excel add-in to be able to visualize data in Worldwide Telescope? Raise your hands. Can I get a count from Boston, roughly?
4.
Okay. So if you've used the Excel add-in, that's already been running through the LCAPI. It uses only the public interfaces of the LCAPI to be able to do everything it does. So it's got a lot of capability. And if you notice, the Excel add-in shows the current status of the layers. When you change the layers, the UI automatically changes inside. When you have, you have full two-way synchronization of the LCAPI, and I'll tell you how that magic is done a little bit later. So, first of all, let's go ahead and take a look at our solution here, and we're going to go ahead and look at HTTP layer API. And so those following around on the GitHub, you would find this under GitHub, the Worldwide Telescope Windows Client project. Pardon me, I'm going to go ahead and bring follow that on GitHub so you guys can see. Maybe a little bit big here. Okay, so go ahead and find the Explorer 3D here, and then we're going to find HTTP layer API. So here we go. Okay, so we're going to take you here, and we're going to see some of the code in here. One of the things you'll notice is that we have a list of settings that have been marked as safe to script against from the external, and those are projected into the LCAPI space. And we have this process request, which is where all the magic is going to happen for mapping. And so we're going to look at things like command, and we're going to look at various commands that can be executed here. And so there is command, dispatch command, a notify command. Here's an interesting thing. Here's a layer list command. So one of the first things we have to do is actually set up an HTTP connection. So we can connect up either directly by the IP address or just do localhost. And so what I'm typing in here is http://127.0.0.1. There's no place like home. /layerapi.aspx, and I typed it wrong. ASPX, and then I go question mark command equals layer list, and I get a 404. So I'm going to double check here and make sure. LayerAPI.aspx, LayerAPI.aspx, 127.0.0.1. Let's just try it as a local host here.
Oh, you have the server running on different ports?
Oh yeah, duh. Thank you, people. So first thing you have to do is you have to run the right port, and so so if you just go to the just local host, you won't be it's not bound to port 80 by default, which is where it looks like it, so it won't interfere with other servers. We have a web server, and if you look at webserver.cs in the same directory, you'll find here that we are going to be listening on whatever port this is, and that port appears to be 5050. And so if we go ahead and now put in :5050, hey, we got success back. Well, if we look underneath the success, we have some XML that is going to give us all the information regarding those layers. So the status success is the only thing you're going to see if you're looking at it in a bare web browser, but if you view the source, or if you load it into, if you take that same command that we did here and use Microsoft's other browser called Notepad. So I don't know if any of you realize this, but Notepad is also a web browser. And you just go open, and you paste in the URL you want, and you click open, and voila, like magic, you have your contents of that URL into your Notepad. Okay? So try that in Mac Editor and VI. Yeah, so from here, let's go ahead and
Jonathan, just to let you know, this is going to stop, and I sent you an email that has the new Hangout link. So when this stops, I'll start up a new one, and you should join to it. Oh.
Okay.
5 minutes.
Oh, 5 minutes. Okay, we have a little bit of grace period.
What happens with in 5 minutes with the?
It will probably. We still may be connected, but it'll stop the broadcast. So some notification come up. I'll yell at you. Just make sure that you listen to me and stop this Hangout, and the one in my email is the new one to go to.
Okay. So here we've retrieved data. I'm getting an echo from you, Doug. So here we've retrieved data from the LCAPI, and this basically is showing us, sort of the hello world here, where we're actually seeing all of the layers that are currently set up in Worldwide Telescope. And this has got enough information that we could actually recreate the layer manager, because we have a hierarchy, we have the state, the names, we have the type of object that each of these has, and all of the objects either have, like, reference frames are always referenced by name, and layers always have a GUID ID. So now any of these settings that we want to activate, we could actually call another API to change the state of any of these layers, and we can also add new layers to any of the existing reference frames. So if you're going to be letting a user browse, the first thing you'll want to do is see the current layer list. One of the other things you'll notice is it says version equals 2. every time Worldwide Telescope starts up, every time someone makes changes to the contents of the layer list, it increments the version. So you can actually do a poll that says, HTTP long poll request that says, hey, come back after 2 minutes, or if the version changes. So you can actually have a background thread that goes in waiting for changes from the interface, so that you don't have to do polls from constantly pinging the server, getting the data and parsing it, looking for changes. It can actually tell you. You can monitor a specific item or a group of items and basically say, tell me if any of these things change. And then that lets you know, if you have a synchronized user interface, that things have been updated. So now we have a list of everything that's gone in here. But now we can do other things, like go ahead and create a new reference frame and provide it all the values. We can set certain settings by going ahead and formatting a LCAPI request. So how do we go about finding out what we can do with this? So you can type in WWT LCAPI, and let's go ahead and search for this. And then let's take a look here, and we have a document, and this has a list of commands that have currently implemented. So we have like activate, delete, get props. Get prop gets a single property. Get props gets a whole list of property. You can deal with having groups. The layer list command that we just showed. Load. This is kind of interesting. If you have data and you want to load a file into Worldwide Telescope, you can call the load command and point it to the file you want to load up, and it will go ahead and bring it in for you. You can change mode, so you can switch to the various different modes in Worldwide Telescope, including Earth mode, planet mode, sky, panorama, and now sandbox. Move allows you to move the view around, and so you can actually use these commands in the LCAPI to make sort of a remote control. So you could put like a web interface on top of this that, as you tapped buttons, it could remote control Worldwide Telescope to go do something. So these are some of the parameters that you can run. You can also add to any request additional parameters on them. So, for instance, when you want to fire off a request to switch to a mode, you can also add some things like date times, time rates, fly to. Okay, can you guys hear me?
Yes.
Are we looking at? Yes.
Whoa.
Oh. Okay.
Clicked on this frame again.
So I like the infinite hall of mirrors there. Okay, so one of the questions that was asked in the break time was, does this local host service just start off? Isn't that like a hacking endpoint or something like that? Can you control it? Well, the reality is that the LCAPI will work on or off the machine, but by default, you have remote access controls that are set. So, for instance, if another machine wants to connect and control your machine, and they would try to connect, and they would be denied access to your machine. It would basically give them a HTTP unauthorized and reject them. Now, what it would also do, though, is it would add their IP address automatically to this list, to this little dialog here, so you could add them to an accept list. so that if you want to sort of whitelist people, you can also use wildcards to accept only people from your local network, only specific machines, and such, so that you can do it. Now, one of the things that is in here is you can say accept local connections, which means this is if you want to shut off the LCAPI altogether so no applications can actually talk to Worldwide Telescope, you just uncheck this. But you can also make it so that you can accept all remote connections, so that anyone who tries to connect to your thing will be allowed, so there will be no filtering by IP. And so this is your way of preventing unauthorized access to it. So for instance, if you were in a planetarium and you had a Wi-Fi network that you wanted some presenters to be able to run a planetarium control iPad application for, right? You could take and whitelist those IP addresses that were given to those tablets while preventing some random kid in the audience from connecting to LCAPI and trying to slew the dome to look at Uranus. So, sorry, bad astronomy joke. But this is the remote access control. You'll find it on the settings menu. Okay? So, once we're in LCAPI, we now have the ability to go ahead and map various tabular data you can do all sorts of other things, but for the most part, what we're looking to do is get tabular data in LCAPI and then change the way that we represent it. So we're going to go ahead and load up Excel, and I'm going to actually grab a table of some data, and I'm going to grab, let's see, some astronomy point data here, and this is part of this CFA2 study or something like that. And so I'm going to copy this data in, and I'm going to go into the sky mode, and then I'm going to go into the reference frame of the sky, and I'm going to paste CFA2. And so right now I'm using the user interface to put tabular data into Worldwide Telescope, and we're going to see what this does when we then query from the LCAPI. Apparently, we don't have we have a megaparsecs thing that we can use that's distance in megaparsecs, and let's take a look here, and let's do Gaussians, and per column literal, let's just do is color. Okay, there's color next, and there's no dates on this, and so here we go. There is the CFA2 redshift study. Okay, so that was brought in to plot on our in our system here. So if I take the go back into our handy dandy notepad and go ahead and open up. Oh, okay. I'm sorry, I killed that. Localhost colon 5050 / layer API.aspx question mark command equals layer list. Okay, so when that command is executed and we bring that in, you'll notice here that under the reference frame of the sky, we have a new layer, and it's called CFA2 here, and here's the ID, and it's of a type spreadsheet layer. It's currently enabled, and there's the version. Okay, so if I go ahead and we want to do something interesting with this, let's go back to our layer API, and let's go ahead and see what we can do in terms of modifying the layer properties. So we have a layer already, and we want to set a property on it. So let's look at the set property command here. So it's going to require an ID, a property name, and a property value. Okay. Well, that's interesting. But right now, what properties does that layer support? So let's pop up another copy of Notepad here, and we're going to go ahead and open up http://localhost again, sorry for all the typing, and layer api.aspx command equals get props, right? And then we're going to say ampersand ID equals and the ID for that. And hopefully, if we did this correctly, we now have all the properties for that particular object. And so here it's a class of spreadsheet. Its dynamic data is set to false. Auto update is set to false. The data source URL is empty. It's not a time series. That's the begin range, which means that it essentially the begin range and the end range are infinitely in the future and infinitely in the past. So that means essentially it's an empty set. It's got spherical coordinates. It tells which the latitude column is, the longitude, where the geometry is not set. And this basically has all the properties that that layer is capable of setting. And so what I've sort of done here is I've reflected that layer to find out what I can actually set it to. So I don't necessarily, in this case, need a manual to tell me which layer. So if some new layer type comes up that isn't documented in the manual because someone else writes it, this layer is actually going to be self-describing so that it lets me not only know what its current properties are, but it lets me know what properties it's going to allow me to set. And so one of the things I can say here is that there's a scale factor of 16. Okay, so that's kind of interesting. So what I'm going to do here is go up and write another URL in which I'm going to change that property. And so what I'd like to do while we're doing this is have the CFA, a Redshift survey there, actually opened up on the side. Okay, and so I'm typing in the layer API. I'm saying command equals set prop ampersand ID equals, and then I'm putting in that big huge GUID that we used before. And then I'm going to say, let's see, where is the things we want? Prop name and prop value. Okay, so I put answer prop name equals, and over here it's scale factor. And then I'm going to say prop value equals what I want, which is going to be, okay, so right now it's already 16, so I'm going to make it 64. Okay, so now when I click on this and open it, you notice all of the points just grew by a factor of 4. So I did this from Notepad. Okay, so if any of you guys can understand how I just programmed changes on Worldwide Telescope from Notepad without a language by just inquiring about this. So that's how loosely coupled it is. If you have any type of language anywhere that knows how to do an HTTP get and post, you can access all of this functionality of Worldwide Telescope by just getting information from it, parsing the XML, and writing it back. So this is a introduction to the LCAPI. I think right now Mark Subrow is, I'm going to put him on the spot if he's still there. Is he still there?
Yes.
Okay. I don't know anything about Python other than it has something to do with Monty Python and spam a lot or something. I don't know. But Mark has done some work, a lot of work with the LCAPI and with some folks who have put together some Python libraries to wrap it. And what I'd like to do is put him on the spot and see if I can get him to talk for a couple of minutes about some of his experiences with it, and maybe talk about that library that he's used just a little bit, and let people know where they can find out about it. And also, if you want to hit him up locally when we start doing side projects, I'm sure he would love to point out where the stuff comes from.
All right, let me just try to manage my windows.
Are you going to try
Am I talking?
Share?
Yeah.
Okay, I'm going to turn off my screen share for the time being. Or do I need to do that for him to share?
I think you can stop. I'm going to mute this.
Good.
The multiverse.
Are you muted, Doug?
John just comes out of it.
Okay.
And then John.
We will hear Mark in the room only.
Hold on a second. I got way too many windows open. Blah blah.
Now we never hear his voice.
Thank you, Mark, for putting up with me putting me on the spot like that.
A second. Where are my? Where is? Oh right. So it's here, but let's see.
You might ask them if they can hear you.
Okay. Hold on. I'm completely lost. Sorry.
I apologize,
Yeah,
Mark. I should have got you a little bit more warning.
Move to new window. All right, sorry. And Google Hangouts. Am I unmuted?
We can hear you.
Can you hear me?
Yes.
Am I talking?
No, you're
Jonathan, wave if you can hear me.
Yeah.
We can hear you.
Okay, sorry, man. All right, I'm going to try to share my screen, but what I realized is I couldn't share with a... Oh, hi, Becky. Yeah, sorry. You should have told me earlier. All right, let's see. Screen share. Yes. All right.
Do you have speakers on your? You can turn up in case this we can hear what they're saying, or is that not?
Oh, right. I don't have speakers on this. Yes. Yeah, I don't know. We can't hear you, so if you have a question, type it in the chat, please. I put a link in the chat, which is to this repository that I set up for the Worldwide Telescope workshops that we had, and basically it's taking advantage of this nice library that John Zuhone wrote that has both sort of abstracted in a Python way all the LCAPI stuff, and also created some nice helper functions for doing things like creating color maps and dealing with time series data and what have you. So you can, if you go to this site, you can click on some of the ones. The first one, let's see, I will click on the visualizing the The gamma survey, it has some more of a, this one has a little bit more of a background for people who aren't familiar. It's basically showing off that Python's got some really nice functionality for dealing with astronomical data now through AstroPy. So you can do all of these things like deal with coordinate transformations, calculate cosmological parameters, and there's this other package called AstroQuery, which allows you to query databases. So this whole thing is sending a SQL query to a database. It pulls back a table. I then one of the calculated cosmological distance from the redshift, and one of the nice things about one of the challenges has always been like there are lots of ways to measure a distance, and it depends on cosmological parameters. They're always changing, but AstroPy makes that really easy. So we just imported the Planck latest Planck results. We get distances. We get this catalog. We ship it to Worldwide Telescope, or we set some visualization parameters as a Python dictionary, send it to Worldwide Telescope, and that's a 3D view. This is kind of a zoomed-in 2D view, sky view. There are a couple other examples here which are nice as well. The Milky Way one just shows off. It's pretty quick. I can go from the Vizier. I've got 13,000 astronomical catalogs I can choose from, and it's just I pick out. So one of the things has always been like this sort of digital universe type functionality in Worldwide Telescope. This basically creates at least a digital galaxy part of digital universe with newer catalogs in almost all cases. And it doesn't take very long, and when newer data sets come, you can just reference those data sets. So this is plotting them here, but there's just this send to button which would launch all these in Worldwide Telescope. The repository, I think, also has the layer files that came out of this, and you can also deal with some time-varying data. So this one is a lot of fun. So if you want to work through this one, but yeah, and I'm just viewing the notebook now. I'm not trying to run it, which I could, but this one's fun because you can show 4 years of observations of gamma ray burst. You can put in the background gamma ray sky, and you can watch them go off, run time forward really fast. So there's just some quick examples, but yeah, check out the repo, and let me know what you think. Some of the others show more work with the color maps and some of the other functions. Doug, can you, Doug? We lost Doug. I'm gonna turn on hand back control.
Okay, so I guess you guys need to turn the volume back on to hear me.
Did he?
Yeah, so we can't hear that.
Yeah, so
all right, and where's the volume on this thing?
Click on Jonathan.
Whoa.
okay, I can see Mark again. Can you guys hear us again?
Yeah.
Yeah.
There's a volume thing there.
I just turned my volume up, but until you figure that one out.
Okay.
Yeah, it's not going.
Are you guys still in Cambridge? Mark, are we just seeing things from Mark's laptop right now? Hello?
Well, we can mute for a little bit and let
Wait, is there? Maybe it's done in Google Hangout. There's a volume thing there. It might have, if you scroll the mouse up.
We're getting echo.
Yeah, that to
We're
the
getting
right.
echo again.
There. No, the middle one. Yeah. Oh, that's bandwidth. Sorry. We're trying to get the volume back on now.
Oh, you want the volume on now?
Just click away from that.
I'll mute. Say something?
Hello, can you hear me?
Yes.
Okay, we're back. Thank you very much. I appreciate that, Mark. We're still just watching Mark right now. Is there let's see, is Doug the one broadcasting?
Yeah, let me, okay, this is back up to, well, to the room.
Okay, so that's a bit of an overview of the LCAPI. I think we were talking, from a time perspective, we're essentially getting to be a point where we're going to have to condense 3 talks into one. So what do we have left for time right now, Doug?
Well, I kind of sweet talked the guy, and we have to be out of the room at 7, so we have like 25 minutes.
Okay, so at this point, I think that maybe potentially the best use of our time would be to actually do some breakout groups while we let the chat hang out, and that we start talking about some of the ideas that we have to how we can use it, and do some Q&A while folks are all in the room to be able to answer in terms of ideas and such.
I think that's a good idea, because capturing that is one of the goals of the workshop.
Right. So I think what we'll do is we'll turn the lights on here and start chatting amongst ourselves about what ideas we have and some of what we can do, the resources and how we, problems and how we might attack them. So thank you, everything, and again, thanks, Mark, for jumping in with the Python stuff, because that's you've done a brilliant job of making that work, and I've been really super impressed. And that's what open source collaboration can do. People can bring their own expertise to this, and so, if you see a need, meet a need, and you be a hero.
No, thanks, Jonathan. Thanks, Ron. I thought both your talks were, the many that we did today were really well done, and will provide a great resource for the whole development community going forward. The plans are, this is being, if you go to my YouTube channel, it's there now, but because of the technical stuff, I want to cut those pieces out before I kind of let everybody know the link. So one thing is I'll be putting that up as soon as I can do that work, and then so expect that pretty soon. And then the other thing is I will send out a post-conference work survey, and so if everybody can make sure to fill that out on both on the Redmond side and the remote people and the Cambridge side. So, but thanks for people who, whether they walked across the street or drove in here or flew in here, this has been fantastic to get this number of people together and to hear some of the cool. We had a lot of conversations about what we want to do with it, what we have plans for it, and this kind of lays the groundwork for that actually to happen. So thanks, everybody, and thanks to the Moore Foundation for financially sponsoring this workshop, and to the Brave New Software Foundation for administering the grant, and the AAS, and for all of us, and we'll be one happy family going into the future, kumbaya and all. So